your data sets into two parts for training set used to teach the model and testing set used to evaluate how well the model performs. Yeah, so you load your data, yeah, and drop any unnecessary column if presented. And then here we explored our data set. And then here we presented the target for the prediction that you're going to do. For example, TV and sales. And here we split our training and testing sets into 80% training and 20% test. And here we built our model. We built our linear regression model. Here we did our metrics. We first created the predictions and then we did our evaluation metrics here. For example, this one, it calculates the average of absolute differences between actual sales, that is the y-test which we defined over here, and the predicted sales by period. Also, we did this one over here, which calculates the average of the squared errors, and here we pretend the results. Here we went to the visualization of our regression line. As you can see over here, we did a comparison for the advertising versus the sales. And here we plotted the, the scatter plot, and this shows the regression line over here. We also did a comparison for the sales, which we created the average average spend of the channel, for example, TV, radio, and newspaper, which we looked for the mean for each, and then we created a bar chart over here, which outlines the average spend of each channel. We also plotted a line graph over here. The line graph presents it presents the differences of units of sales between TV and the sales. We also created a distribution of sales using a histogram. Which we compared the units of sales between the different TV, radio, and newspaper, and their frequencies of sales over here. Yes, that's our presentation.
Nice work, group 3. And also, like, nice work to all the groups. Like, I'm glad, like, you all cooperated and collaborated and came up with these amazing projects. Just like area of correction feedback for group 3, it's good to do an EDA first to see how data is distributed, because some data cannot be modeled by linear regression. So when you see it before you actually model the data, you'll be able to see if it's good to use linear regression or not. But also, like, everybody has done a great work. Commend you, ladies. Good work. So I'm going to share my project. So for me, I did for that data set, I did a linear regression model. I also did I did another mini project with the same data set, where I did like I did the ridge regression. Okay, I applied the ridge, I applied the lasso, I applied the elastic net just to see. And I also, with the same data set, I did a polynomial regression. As we said, we have like several variations of linear regression. So when you have the data set, you can still like play with it. So this was the original. Mine is pretty the same as you guys, like uh, just checking the data, getting to know my data. Okay, I just do a high level, but I'll share the files with you. Just exploring the CTV, the radio, and the newspaper. Group one had something similar to this. It helps you to see the distribution. These ones are histograms. At least you get to compare and see how they match against one another. It's a pair plot. Yeah, just the same thing. The zero residual line, I plotted it. Yeah, so the only thing that I've seen that none of the group has done is this part. So I did a scatter plot of prediction versus now the real ones, like when I did the prediction. So mine I visualize with a scatter plot because I can be able to see like how the points are predicted. Yeah, but that's like how you choose to view, or how you choose to view your prediction still. As long as the model is performing well and it's predicting well, it's a good sign. Yeah, so this other one, this was just where I used like lasso. I want to go into much details because I'll just share with you guys so that you can do more. So I did ridge one, and this is still ridge, and lasso, and I think an elastic net. And also I also did a polynomial one. So this one is now where I'm going to explain more, not explaining per se, but you see the procedure is the same, library is the same. For polynomial, you can see it's still like the same old, but that's not what I want to show you guys. I also did a small comparison to see my train and test how it's doing. Yeah, it's a lot of comments. So this last part is where I'm rushing to this part now. So after you've trained your model, you can save your model. So when you're satisfied with your model's performance, for example, for group two, your R score for the combined for both TV, newspaper, and radio, it was 0.89. That's like 0.9. That's like a good performance. So as you can all agree, it's nowadays you can train 90, but sometimes you just get satisfied with your score. Then you want to save your model. Maybe now you want to use it in an application, in your web app, etc. So why did they even save this model? I think it's somewhere here. Oh God, I don't even know. Yeah, so apologies. Yeah, so this job lib, it's used to save your model. You can save the model, then you can load it and predict with it. Yeah, so I saved my model with this name, final polymodel joblib, blah blah blah. Then I loaded the model again after saving so that I can predict. So when I'm predicting, because the features are already arranged like it's TV, I don't even remember the features. Sorry guys, I've did this in a rush, so forgive me. So it's TV, radio, and newspaper. So you just give it like, let's say I have 149 for TV, I have 22 for radio, and 12 for newspaper. How many sales am I expecting to make? So according to my prediction, it's 14. So this is like The dump is for saving, the load is now for loading the model. So this is like just a final bit that you guys, I've not seen any group do this part, but overall you guys have done great work, and I can say so far so good. We are doing great. Yeah, so with that being said, welcome to today's class. So the previous class we did like a regression. We've all like participated in the test for regression, for linear regression. So you can still use the same data set, explore several things, explore support vector regressor, see how it's performing, polynomial, etc. I still share my files after the class. So today we are going to dive deeper into classification models. Since I'm sharing my screen, I can still just share. So just a recap, we said like the tasks that we want AI to do for us include regression, classification and clustering. But regression and classification is like the biggest of the tasks that we want AI to do for us. So it's good for us to understand at least the basics. Yeah. So the learning outcome for this session is we want to be able to define key classification algorithms such as logistic. I know now they are not new to you anymore because we did an overview of these algorithms in the machine learning class. Yeah. So evaluate the model. We see like metrics. You see for linear regression, we have already done the root mean squared error, the mean absolute error, the R score. But now for classification, they use different performance metrics. So we are going to do more, check more into them. We're going to see, this is a new term. Let me put in presentation mode. So this is a new term, confusion matrix. We're going to learn what it is and how to do an error analysis. Then we are going to do a practical project. Though for this week, I'll just give you the project. You guys are going to do it at your own time. This week's assignment is just it's a simple assignment. I want you guys to just go and learn more about AI. It's a guided assignment, but it's like more for your own benefit. Yeah, so take it as a mini break, small assignment, not intense. Yeah, but then that we will have a project on this. Um, this is just a more on expansion on model testing and evaluation, but it's just a repeat of what we've been saying. We don't just want our model to be good when we are training it, and then when we deploy to real world, it's not working because it's not able to generalize. We talked about a model being able to generalize, and we said like we don't want our model to overfit, because if our model is overfitting, it means that it's going to perform well when we are training it, but when we give it new data, it's not going to perform well. So what we are trying to do, we want our model to be able to learn the patterns in the data so that it can apply that the lessons learned to new data. So that's generalization. So we have different testing scenario, especially when you're doing like a real life project, because you can't just deploy a model and then you've not tested it as robust, because you're going to get a lot of back and forth. So you do a lot of testing, you check every angle, test if it's let's say if I'm deploying let's say even something like ChatGPT, we have to test in all angles. You see, those people have tested that model of theirs so well that when you ask ChatGPT something that's violating like human rights, it's going to give you a warning, because you have to test in all angles, because people can misuse your AI, and if you're not careful, and even you can do a model then it's not performing well, so you've like wasted a lot of time training a model that's not working. So the training part is very crucial to ensure that your model is able to perform well in real life, and also ensuring that you don't go back to scratch and start again. Yeah. Mm. So when you're evaluating for classification, we are testing for accuracy, we're testing for precision, we're testing for recall. We have F1 score and we have ROC AUG. It's called area under the graph. It's like a curve. It's a curve, ROC curve. And also different classification models require different metrics. So we are going to learn in which situation should I consider accuracy to be the most important aspect, in which situation should I consider precision, ROC. They differ. For instance, sometimes you realize like you're modeling. Let me give you an example of a classification. Let's say even for an email spam, maybe let's say you have more genuine email than spam emails. So already it's an unbalanced class. So you can't use accuracy on an unbalanced class. So in real life, data is not as cute as it was. The TV advertisement thingy, that's a good data set. But in real life, data is not as good as you expect it to be. Some classes are unbalanced. Let's say you are doing a population data, then you realize like this population, maybe this population is greater than this. You can't start imputating. You have to have a way of balancing your model to accommodate that data. So those are like real world situation. So that's why we have different scenarios where we consider different metrics for classification. So talking of evaluation matrix, so we have accuracy, precision, recall, F1 score, ROC, AUG. This is like literally this is a confusion matrix, but you can this one is not okay. So I'll draw my own confusion matrix here. Then this is the predicted. Let me say P. Then this is the actual, this side. Let me change my pen's column. So this is true positive. So true positive represents the true, like the model has predicted and it has predicted correctly. So let's say I'm testing my model. Now I can use a different example. I have like a flower data set. I have different flowers, roses, daisies, morning cherry blossoms, etc. So if it has actually predicted that it's a rose and it ends up being a rose, then it's a true positive. It falls in the true positive category. I forgot to put this one is positive, this one is negative, this one is okay, positive, negative. I think that's enough. Yeah. And then this one is a false. I should do a false positive first. This one is a false positive. This one is a false negative. This one is a true negative. So this is true positive. The right predictions. This one is a true negative. This is where the model has. How do you explain this in simple terms? Just a minute. True negative. it's like predicting correctly for a negative. Let's say, for example, for the email spam detection, I think that's a better example. So for the emails that are actually not spam and and have been classified as not spam, they fall under true positive. And for the emails that are spam and have been classified as spam, they fall under true negative. I don't know if you're together. Is my explanation confusing or is it understandable?
Yes, it is.
Okay, that's nice. And then we have the so true positive, true negative. We have the false negative. The false negative is where this is like it has not predicted anything correctly. So this is out. It's like it has not it has just it has misclassified everything. So it's a false negative. Then we have a true negative. No, I've already explained true negative. We have already true positive. False negative is where the model has just predicted everything wrong, and also false positive is where the model has also predicted incorrectly. So these two, for these two, like they have already placed them in the wrong. So you can, for example, an email is not spam, and the model has classified it as spam. It falls there. And where the email is spam and model has classified classified it as not okay, spam, not spam. Yeah, as classified it as spam. Wait. I'm confusing myself. So the email is not spam, and the model has predicted that it's spam. It is falling here in this category. And where the email is spam and the model is giving it that it's not, it's a good email, it's falling here. So this diagonal here, that's the point I'm trying to pass. This, it means like the model is predicting wrong, in short. And this one, the model is predicting right for the classes. So any question on the confusion matrix? Hey, I have now understood why it's called confusion matrix. It's even confusing to explain. So any question on the confusion matrix? Are we together on that? Hello, guys. Are we together?
Yes.
Yes.
Okay. So it's the same thing, but I was trying to at least explain where each class fall. So when you're calculating accuracy, precision, and recall, those are like the biggest in classification. We are using the confusion matrix to actually predict. So you can see accuracy, we are picking the true positive and true negative over all the predictions. That will give you the accuracy of the model. So it's like those that have been accurately classified over now all classification, all everything that was in that model. That's accuracy. Then recall, also called sensitivity in some scenario, we're picking the true positive, the accurately predicted ones, over the true positive plus the false negative. So this one is dealing with the this first part of the confusion matrix. Then we have precision, where it's true positive, the correctly predicted of true positive, false positive. This. Then we have specificity. You might find yourself checking for that, especially when the true negative class matters most. When your spam class matters most more than the accurate emails. We have some situation where, for example, maybe when I'm doing those sentiment analysis and all, maybe I have more positive comments than negative comments, but then for me negative comments matter a lot because let's say I'm in a marketing department, it matters what the client has said negatively about my company. So I can have 80% positive comments, but I'm focused with the 20% negative comments. So you can find yourself focusing on this aspect. Yeah, so this is specificity, true negative over true negative plus false positive. And then we have negative predictive value is also almost the same. It's like we are focusing on this category. Yeah, so I think that's like a breakdown of this. So you can see they're all connected. Accuracy, precision, and recall. We're all getting them from the confusion matrix. So any question? Are we together? Hello guys, are we together? Is this understandable to you guys, or should I repeat?
I think you can repeat, especially the formulas. They're a bit confusing.
Oh, the formulas are a bit confusing. I think I need to erase something. I don't know if it's erasable. Let me use a different pen. So this is TP. Use this one. Let me draw another one here. So the first segment is TP, true positive. And I said true positive is the accurately classified class. I need to use one example for this confusion matrix. So I feel sentiment analysis is a good one. So for sentiment analysis, so I'm going through my review, my feedback system. I have a company that is producing this product. Then I have a session where users can review. So I'm trying to classify positive comments and negative comments. So I have two classes, positive and negative. So true positive is where the positive classes, my model, when I'm testing my model, the positive classes have been well placed. So it has predicted the positive classes well. And true negative, it's where the model has predicted the negative class well. So that my two classes. Then I have a false positive. It's where my model has classified a positive comment into a negative category. And a false negative is whereby a model has classified it's vice versa, a negative comment in the positive category. So when I'm doing accuracy, so we have already identified that this part of the matrix is where like this is like the correct classification. So when I'm doing accuracy, I'm going to pick two positive plus two negative over now the whole confusion matrix over all data points. So it's true positive, false negative, true negative, false positive. So when I'm doing recall, I'm going to pick the true positive over this addition, this part, the true positive plus false negative. When I'm doing precision, I'm going to pick the true positive over true positive plus false positive. But now specificity and this negative predictive value is where the other class matters more. So the same example, maybe I don't have, maybe my two classes, positive comments and negative comments, those are the two classes, but maybe I'm more focused on this other class than I am with this, the class which I'm using to determine this. So I can focus on this other class and focus on the negative comments. So I'll use specificity to see how is my model performing in predicting the negative comments. And the same here. So this is like this is like the explanation for the confusion matrix. So is that clear? Is that clearer now?
I have a question.
Yes.
Is there a specific reason why, for example, in accuracy, we can take the true positive plus the true negative over all of them
Mm-hmm.
because we are trying to get the accurate outcome.
Yeah.
But for the others like recall, is there a specific reason why we take true positive over true positive plus false negative?
Yeah, so for accuracy, it's like accuracy is like the general. How accurate is my model? But now for recall, as you've said, sensitivity. So I'll still use the similar example. Sometimes we're not concerned about accuracy. You're more concerned about how the model is performing when it comes to classifying the class as well. I think this is more sensitive, okay, especially in sensitive data, medical data. Let's say I'm checking if my patient has diabetes or not. I'm more focused if my model is sensitive. Is it like really classifying diabetic as diabetic? Like my accuracy at that point, accuracy does not matter. My model can be 99% accurate, but then it can make big errors. If I lie to somebody that they have diabetes and they don't have, or if I tell somebody they don't have diabetes and they actually have diabetes, I'm more likely to cause more harm you know so yeah, there are reasons why we are using recall instead of accuracy in that situation, or precision instead of accuracy in that situation. So it all depends on the scenario. Sometimes I don't even care about the accuracy. I just want my model to predict true positive as accurately as possible. So are we together there?
Yes, we are.
Okay. Yeah, so I think when it comes to the confusion matrix, that's it. Don't worry about the as I said, the more you practice, the more you understand, and the more it will make more sense to you. So don't settle for just the classes only. Yeah, so more explanation. Accuracy is the ratio of the number of correct predictions to the total number of predictions. This is the most fundamental metric used to evaluate the model. It cannot perform well on imbalanced data sets. For example, if the majority of the data belongs to the major class label, it will give a higher accuracy, but in general, the model cannot classify on minor class labels or has poor performance. That's just like a drawback. So you can't entirely rely on accuracy, especially for unbalanced classes. Precision is the ratio of true positives to the summation of true positives and false positives. So it basically analyzes the positive predictions. Of all predicted positive, how many were actually positive? That's the question that precision is answering. So it does not consider true negative. That's the drawback. It's focusing on the true positive. How accurate has it predicted let's say my main class? You know. So we have the recall. It's the ratio of true positive to the summation of true positive and false negatives. It basically analyzes the number of correct positive samples. What is the proportion of the actual positive class? What proportion of the actual positive class is identified correctly? So yeah, that's the difference between precision and recall. Yeah, this is an example. So assume you have 100 animals that your model should classify. Of these, 20 are dogs and 80 are other animals, e.g. cats, chicken, etc. So your model identifies that 5 animals as dogs, of which 15 are truly dogs, but 20 are other animals, are wrongly identified. Your model misses 5 dogs, but it also correctly did not identify as dogs 60 other animals. Okay, this is this is long. Okay, so we have 100 animals. Let me use a different pen. We have 100 animals. We have 20 which are dogs, and 80 is just other animals, etc. So it has classified 15 as dogs, which is good. Wait. Your model had 35 animals as dogs. So I have 15 plus 5 plus 20. Okay. But wrongly identifies 20 other animals as dogs. So my model has identified 60 animals as not dogs, which is actually correct. Because so 15 are okay. 15, these are dogs, which is correctly identified. Out of 20 dogs, my model is able to identify that 15 are actually dogs. And out of 80 non-dogs, my model is able to identify that 60 are actually non-dogs. So far, it's not bad. But now we have 20 misplaced classes. So as for this, my model has predicted that these ones are dogs where they're not dogs. And my model has said this one is not dog where they're actually dogs. I hope now I have brought the clarity. So when we are actually doing a calculation, you can see precision is 42%, FPR, the other one, is 25%, sensitivity is 75, accuracy is 75. So you can see they perform these metrics for class, they perform differently depending on your data set. So you can see in this situation, if I was actually focused on precision, my model is not performing well. But if I'm focused on accuracy or sensitivity, it's actually doing not bad. Yeah, so this is just a mini example to just illustrate what I've been explaining. Yeah. Oh, and now we have another metric, the F1 score. So from the formula now, we have introduced the F1 score. It's 2 times precision times recall over precision plus recall. Sorry guys, I just feel like these terms are just so much interconnected. So F1 score is the harmonic mean of precision and recall. So it's like it's the mean of precision and recall. So the goal of F1 score is to balance precision and recall. As you can see, precision and recall, most of them, they focus on the true positive class. So it's like it's balancing precision and recall. So there's a precision recall trade-off, this like a term, where it says as precision increases, recall decreases, and vice versa. So in a situation where maybe you just want a balance of precision and recall, you can use a F1 score. So as I've insisted, it all depends on the situation, it depends on what is important at that moment, and the type of data set that you're dealing with. Those are the most important factors. So far, any question? So I know for the my confusion matrix, I've used only like 2 classes. I'm classifying maybe spam or not spam, negative or not negative, and so on. But then real world does not usually have binary classes. Binary classes mostly work for true false situation, positive, negative, yes, no. But now when it comes to other things, you can't still use binary matrix. Okay, binary classification. So a confusion matrix is actually an n by n matrix. So it's not like a 2 by 2 matrix. Don't put it in the head as it's not a 2 by 2 matrix. It's an n by n. But then now when you're explaining, it's easier to understand for 2 by 2 matrix. So most of the time when you're researching, you'll find like most explanation for confusion matrix is actually for 2 by 2, but it's actually an n by n matrix, where n is the number of target classes. So if I'm targeting 10 classes, I'll have a confusion matrix of 10 by 10 classes, because there's a situation where let's say I have a cat, I have a dog, I have chicken, I have a goat, and a cow. So I want to see, as my models recognize a cat as a cow, it matters. So it's an n by n matrix. So this is just a small code snippet. But then for this slideshow, I've put like code snippets that will help you as you navigate. So we have ROC, AUC. This is another metric for classification. ROC is receiver operating characteristics. AUC is area under the curve. Sometimes it will be called area under the graph. It's the same because it always comes as a package. ROC, AUC, or ROC, AUG. So yeah, it's evaluation metric that is used to analyze the classification model at different threshold values. It highlights models' capacity to separate classes. Yeah, so it's actually very useful in real world. A model is considered a good fit if AUC score is greater than 0.5 and approaches 1. So ROC, now the first part, is probabilistic curve used to highlight the model's performance. The curve has two parameters. TPR, which stands for true positive rate. So it basically follows the formula for recall, and FPR, which stands for false positive rate, defined as the ratio of false positive to the summation of false positives and true negatives. So this is also like another metric. So it depends. It depends on your scenario, on your data set, and on what you're trying to achieve. This is just an illustration of the ROC. This is an area under the curve, the ability to separate classes. This is just a visual explaining how it analyzes. So if you actually visualize this, you see for the precision and recall and accuracy, it's in percentages, but when you're actually evaluating a model using this method, you are actually able to plot the curves, and probably your curve will look like this depending on how the model has performed, yeah, and so on. Yeah, we also discussed a bit about overfitting and underfitting. This is just like a repetition. Overfitting is where the model is cramming your data, so it's performing so well on the training data and poorly on new data. And underfitting is the opposite of overfitting. It's where like the model is just it has not learned anything from the data. But now the problem with models, this will be your biggest problem actually. Underfitting, it happens, but it just means like, I don't know. It's that situation where it's a rare situation. If your model is underfitting, okay, maybe it has just not trained well. But now overfitting becomes a problem because you get too excited when your model performs so well. You're getting 99% accuracy. You're like, yes, this is it. So it can be actually, it becomes a problem. Underfitting is easy because you already see your model is not performing, so you can do better. But now overfitting is where sometimes you don't realize your model has overfit, so you're just excited because it's training well, but now you have not given it new data to see how it's performing. Or maybe you can even deploy your model, then in real life it is performing way bad. Yeah, so heavy on overfitting because it's a problem for us AI/ML engineers. So when we're talking about overfitting and underfitting, this is just a repetition. I know we had already talked about bias and variance. We talked about bias variance trade-off. We want our model to have low variance and low bias. So that's how we ensure that our model is performing well. So I won't read so much into the content because we did a bias and variance explanation. This is just a more illustration of on overfitting, underfitting, and when the model is actually a good model. Yeah, so this is code workflow for doing your classification. Because you had already did a group assignment, you already know how it flows. After you've done your EDA, you do a train, test, split. Sometimes you can do a train, validation, and test depending on your scenario. You train the model, you predict, then you evaluate, you check your accuracy score, you check your confusion matrix, you see your classification report to see maybe the important features, etc. So this is just like a flow, and I commend you guys because most of you have already mastered the flow from the previous project. So it's a similar flow to the linear regression flow. Yeah. So we have logistic regression. We said this is just a repetition of the algorithms. I feel like I'm doing a high level repetition because we had already touched on this, but I'm trying to just, make sure it sticks in our brains well. Logistic regression is a binary classifier. but then you can use a softmax function to make it classify more than 2 classes. Yeah. Code example. I think I want to repeat this part. It's just more explanation on the classes, and then with now codes. I've provided small code snippets to help us understand the classification algorithms better. So this is just like it's a repetition, but now with code snippets. So any questions so far? Any comment, any feedback? Have you understood today's class? Hello, guys. So I want to give you the assignment per se as an assignment. So you can choose to do or not, but it's good for your practice. So it's just data set, then at least you try do classification, logistic regression, yeah. Support vector classifier, you can do decision tree. It will help you like learn classification more. Yeah, but this week's assignment is just about watching a certain YouTube video to learn more about AI. So any question, any comment? Sharon, hello.
Hello.
How was the class?
It was interesting.
So have you learned something from today's class, from presentations to the classification bit?
Yes, I have.
Okay, that's nice. So guys, any comment? I want to learn if you're actually okay with the progress, if you're understanding what you're learning, if you have any concerns, you can raise it here.
I have a question.
Yeah.
Will you be able, okay, can you please send the slides to the group so that yeah, I can learn deeply into it.
It's okay. Yes, Karen, I will. Actually realized I didn't send for the previous class. So I'll send for the linear regression one, and then I'll send for today's class. So yeah. Of course I have two. And also, just an announcement. So next week's class on Tuesday, we have decided to merge the class with the data science track. So our track is AI/ML. Then we have a data science track going on. You're going to learn about PySpark. Maybe the word might sound new to you, but don't worry. So in the bigger picture, PySpark is essential when you are doing real world um, machine learning or AI, because you are dealing with big data. So PySpark basically deals with big data. So it's like an opportunity. We have like a guest tutor. So I felt it's a good opportunity for you guys to learn maybe something more than what we will cover in our class. Yeah, so it just the class, so we'll attend that class, then now we can bounce back to our normal classes on Thursday. And now from next week we'll be doing natural language processing also. I think when it comes to now machine learning, I can say we are good, so we can go to deep learning as per our track. So yeah, that is the announcement. So any question? So if you don't have any question, I can release you guys for today and also for this week. And also we are almost closing the boot camp. Next week it's week 5, week 6, week 7, week 8. So at least do reflections on yourself, see if you're learning. And I always insist, learn as much as you can. Learn from, we have a lot of resources out there. Learn as much as you can. And just a word of encouragement, upskilling is like a continuous process. Like, don't settle, don't just do one linear regression project and then that's all about linear regression. No, because you realize like we have a lot of factors. Data is out there, data is so diverse. So anytime you're doing a project, you'll always find a small challenge or a different type of challenge. So keeping yourself in the learning loop will help you, keep yourself up and also learn more. And also, another form of encouragement, check out things about AI, because now you're already interested in AI and ML. So you can check out some AI news, see what's happening in real life, see what people are doing, see what AI projects are actually like selling out there, see what you want to, do when it comes to real world projects. And also, like when you were starting the class, some of you wanted to join AI because you want to see where you can use AI in your own field. So you can do research, see where AI fits in your field, what you can do about it, and so on. So keep learning, keep researching. Don't get tired. You just started. You have a lot to learn, improve on, and grow. So that's all I have to say. Thank you for attending the class and also have a great weekend ahead.
You too.
Okay.
You too.
Thank you. You too.
You too.
You too. Thank you.